Thanks everyone for coming. We'd like to thank Capital Factory, Mobility X for allowing us to use the space here. It's really nice, so we're super grateful for that. And then I want to thank the Austin Ethereum meetup organizers for giving me the chance to do this. It's really nice to meet everyone here, meet all the other Ethereum enthusiasts in Austin, so really happy to do that. So my name is Josh Hannan. I'm a co-founder of Majoolr, and we are working on building secure systems for the Ethereum blockchain, and just working on helping educate everyone to become better blockchain and Ethereum developers. So what I'm here to talk about today is library-driven development in Solidity. It's kind of what we're basing our work on at Majoolr, and it's something that we think it would be extremely positive if more people in the Ethereum community would adopt this kind of style of development. And so we're gonna walk through the need for libraries and how to use them. So just want to start out by asking how many people in here are active developers right now? Not just in Ethereum, but just in general. And how many of you guys, have done work with Solidity or done any Ethereum development? All right, awesome. So unlike more popular languages like JavaScript or Swift, Solidity is right now it's kind of limited in what it can do as a language, because first of all, the Solidity or any other language that compiles to EVM bytecode, it's because of blockchain, just the mechanics of the blockchain, it has to be run on every node in the entire network, and each node has to verify the integrity of any transaction that is run on the blockchain. So because of this, you've got millions of nodes around the world, and since they're all running it, computations on the blockchain are going to be kind of expensive, and so there's a little bit less you can do with the language, and any heavy computations you're going to do are going to be a little bit harder to do because just execution costs a lot of money, and so. Another thing about Solidity is there aren't any standard libraries yet. If we're talking about like C or JavaScript, you've got like the C standard library, you've got like underscore or like Lodash for JavaScript that handle all of these common functionality and that we can trust in any type of application we're using. But right now, Solidity doesn't have any libraries. Another problem with Solidity is that it's hard to access external data. You have to use what's called an oracle, which is like an external call from your smart contract to a program in like outside of it, which also costs a lot. So just getting regular computation done in Solidity is a little bit challenging. And then one last problem is that you can't really upgrade your smart contracts very easily once your code is deployed on the blockchain, and that's just kind of like part of the blockchain. Since when you deploy these transactions, they're immutable. Finding ways to upgrade them and making them easier to use is a lot harder because you don't have as much flexibility as you do with regular production languages. Right now, developing Solidity is a little bit challenging, and one problem is that right now everyone in the space is kind of like working in their own little silos and writing all their own code, and that could be a problem because not everyone is aware of all the best practices for Solidity and not just Solidity, but just for blockchain development in general. And so there's been a few high-profile hacks on some of these programs. Like last year, there was the DAO hack, which was an exploit in their smart contract code. And then just a couple months ago, there was the Parity multi-sig wallet hack, which was just another exploit that the developers at Parity got wrong, and they lost millions of dollars. One of the people using their wallets lost millions of dollars. You've got all these millions of dollars flowing through these contracts that are all written by developers that, while they're good developers, they're human, so they make mistakes. And the coding standards for Ethereum and for Solidity development are not, they're getting better and better every month, but they're still not like a well-developed standard for coding practices, security practices, or libraries on it for Ethereum. So that's why I want to talk about libraries and why we think that everyone should be working together to make standard libraries for Ethereum, using the libraries, and working on using libraries in your own project for any common functionality that might be just local to your own project. I like to go, so just to kind of recap the pros and cons of using libraries for Ethereum development. One of the pros is that it reduces deployment costs. When you write your contract and you deploy it on the Ethereum blockchain, that's always going to cost a certain amount of gas, which is like kind of like the currency that's used to pay for running these transactions on the blockchain. And if you're using libraries and you have less code to deploy because you're calling these external libraries, it's going to cost less to deploy your contracts. It provides reliability because if you're using these trusted libraries that either someone else wrote or that you wrote yourself and you've tested very thoroughly, you don't have to worry about testing that part of your code when you're working on a different project that uses the same functionality. And then that also applies to the security of it. You know that these have been tested, you know they're secure, you know they follow the best practices, so you can focus on the actual important parts of your own application. But there are a few drawbacks of using libraries right now. Execution costs will be a little bit more because if you implemented all the code in your contract, all the execution would happen within your contract. But calling an external library requires an external call, which does cost a little bit more to do. Deployed libraries on the Ethereum blockchain, like I was talking about before, are mutable. So people have run into some problems upgrading. Like if you want to make a fix to your library, you have to deploy a new instance of that library. And then tell everyone who's using your library to change the address that they're using to access that library, which can be kind of a hassle, but there are solutions to that are forthcoming, and we'll talk about that later. And then also just understanding someone else's code can be a little bit of a hassle sometimes if it's not well documented or just having to figure out what's going on. So, but I think that libraries are a lot better idea to use than just writing everything yourself. So now we're going to go into kind of what a library kind of entails in Ethereum. So a library in Solidity is kind of like a regular smart contract, except it has no storage and cannot hold any ether. So it doesn't have any payable functions. Payable just means a function that you can call while sending ether to as part of that transaction, and doesn't have a fallback function. And a fallback function is a function that's called when you send ether to a contract without an actual function call. So the libraries are just for just executing like different functionality. So when you include a library in your smart contract and you call it, the context of that contract is passed to the call of the library. So the library kind of acts as like an explicit base contract of your contract. So it can modify the storage of your contract, and it any logs or events, any events that it emits are stored in the calling contracts event log. So the way this works is that there's a special opcode in the Ethereum language called delegate call, and when you call a function with delegate call, that's what passes the calling contracts context to the library, so it's able to modify any things in your contract as if it was a function in your contract. And as you can see right here, this is what the bytecode of a function call looks like from your contracts when you're using a library. So right here, this is a function signature for the function you might be calling, and then it leaves this blank space right here, and that's where the address of the library gets filled in when you deploy it on the network. So it puts the address in here. It has the function signature it uses to call the function, and then whenever someone calls that, it'll know which address to access when you call that. I just want to give a quick example of what your code might look like if you write all your code in just a contract, or if you write a code in your library. So I'm going to switch over to my development environment. So on the left on the right, this is a contract implementing a standard ERC20 token, which, in case you don't know, is kind of the standard type of token that anyone uses on the Ethereum blockchain. So we have all these functions that you have to do all the functionality for transferring tokens, finding the balance, transferring from separate addresses, approving transactions. So it's going to be a lot of lines. Whereas if you use a library, all you really need are just the function calls and any other things you need. So we just have the function calls, and we just have functions to get the values of certain storage variables. And in the library, you can see that that's the contract. We're gonna look at another library in a little bit. So, like I was saying before, libraries, when they emit events, events are what any web apps, they can monitor for these events to kind of see what's happening in the contract. So usually if something important happens, if you're registering a user or modifying something important, you'll emit an event, and then that's how any web apps can see what's happening on the blockchain and update whatever they're doing for that. So it uses the contract's event log. So when a library emits an event, that's stored in the event log for the contract that's including it. But unfortunately, right now, when you compile your Solidity contract, it creates something called an ABI, which is kind of just like a JSON file that holds all the information about all the events and functions in that contract. Unfortunately, any libraries it's including, the logs aren't included in that. So that can kind of confuse the Web3, which is the Ethereum JavaScript API, when you're trying to access these event logs. So a way to get around that is if you define the events from your libraries in your contract, it will pick up any events that are emitted from the libraries and stored in the event log so that it is accessible from any web apps that you might be using to monitor it. I'm going to go through a demo here. We're going to work on just making a simple contract that includes a library, and then we're going to run it, test it with Testrpc. And so when you're deploying these contracts and libraries, you have to remember to you go through, you have to link the library to your contract, and you have to include the library in that contract, and then deploy them after they've been linked. So I don't know if anyone saw, I updated the meetup page earlier today with just like some instructions. But if anyone wants to participate in this demo, you're more than welcome to do it on your own if you have Truffle and Testrpc installed. But we're just going to really quickly install a library with the Truffle demo that you get when you just initialize a Truffle project. So I'm going to just make a directory, and I'm going to go to that and just do a Truffle init. So basically what we're going to do is we're going to use Truffle's default contract, and we're going to, they have some mathematical operations in there. And one thing that you'll learn in Solidity is that when you're doing any mathematical operations, if you're just doing the regular math operators like addition, subtraction, they don't have any protection for integer overflow or underflow, which has been the reason for a few hacks. So they've been created for safe math functions that you can call that check for overflow and underflow, and you can make sure that that's not happening when you're doing these operations. So now that we have this Truffle directory, what we need to do is we need to go to the MetaCoin. So that's just the default contract we have on here. So right now you can see that they have like the plus and minus for the balances. And on the meetup page, we have, oh no, I might have closed it. All right, on the meetup page, there's a link. There's a link to the files that we'll need for this, and really all we need is basic math library from our repository. So I'm going to create in the you put the library in your contracts directory. So just BasicMathLib.sol, and then save it, and then in your actual contract at the top, you'll just do an import of that library. And then one thing that makes libraries very useful is that you can use the using keyword to allow you to use a certain data type to call the function in the library as if you were calling like a method of that variable. So for that, we just add a using BasicMathLib. I think it was 4. Yeah, for uint 256. And then also I'm going to change that balances to uint 256 so it's so it matches up. And then on this, so for this balances, it is possible for this to underflow on this subtraction. So all you need to do is our library returns a Boolean to indicate if it succeeded or failed, and it returns the result. So you have to declare Boolean error and then uint 256 result, and then it would just be error result equals balances message sender dot plus. or minus, sorry, minus amount. And if there's an underflow on that, it'll return an error for that. So we'll just do a require, requiring that there's no error. What a require does is any conditions that you need to check for in your contract, you'll put in a require, and if that condition isn't true, it'll revert everything in the entire transaction, any changes that it made to the blockchain, and just completely cancel that transaction. So if there is this underflow or an overflow, then it will just totally cancel the transaction, won't have to worry about anything. Do you have a question? Not really. I think it's essentially the same. They are in Metropolis. They're introducing the new a new revert opcode, and I think when Metropolis or when Byzantium comes out, which is the first stage in the Metropolis hard fork, they are going to change assert and require so that they have slightly different functionality, but I don't remember off the top of my head. Yeah. Oh yeah, you was the one. That was one that you wrote, right? Oh, okay, never mind. But I at least know that require is something that you should be using at the beginning of your functions to check for do precondition checks. For example, if if the sender's balance is less than the amount, return false. You would say require balances be greater than amount. And then assert is something that is used, you should use for checks later in the function. So actually for this error right here, I probably should use an assert, but I'll save that for another time. So now that we have that in there, you have a question? Can you? Yeah. I don't think so. It just stops everything. Any function any contract that's calling it, if you hit a require, it reverts everything in that entire transaction as if it didn't happen. So even if it was just in an external function you called and you still hit that, it would still just totally cancel everything. So it refunds any remaining gas from the transaction, but any gas that was already spent is gone because the computation has already been done. Yeah, so I'm just going to do this this math operation for that first thing right there because the other one is almost exactly the same. I will. Oh yeah, so then once you check that, you'll just say bounces message sender equals result because you know that it went through correctly, and so then you can update the state of the contract. So then what needs to be done next is we'll compile it to make sure that I didn't screw anything up. And looks like everything's good. So then what needs to be done next is you need to make sure that you have the contracts ABI, which is that JSON object that describes the contract in the build contracts directory. So we're gonna go there. It should have when it compiles, it should make that. Yeah, so we have the BasicMathLib.json and Metacoin.json, so we're good on that. If you were using a library on the actual the actual network, you need to make sure that your ABI, your JSON for that library is identical to the one that's already deployed on the network, because that's how it accesses those libraries, by using the address and then matching that with the ABI of the contract that's deployed. So normally we would also take the JSON for that library and copy that into our Truffle directory. But since we're not doing any network deployments right now, then we wouldn't need to worry about that. But it probably would be equal anyway. But it's usually just good to make sure that you have that same. So the last thing we need to do is we need to edit our migrations. Wait. Oh, I'm in build. Okay. We need to edit our migrations file. So it's called to deploy contracts, and this is the file that it links your libraries and your contracts, and it actually deploys it to the network, whether that's Testrpc, which is just the test network, your local test network, or if you're actually using one of the main network or the actual test networks. So in this one, it already has a few things for what's in there right now. So we'll just need to include the BasicMathLib library. And so artifacts require BasicMathLib.sol. And like they have here, we deploy the BasicMathLib and then link the BasicMathLib to the Metacoin contract, and then it deploys the Metacoin. So in there we've just linked everything. We've added the commands to deploy it, and so then all that we need to do now, I'll give anyone who's doing it, you can look at it a little bit longer, but all we need to do now is just run the command to deploy it on our Testrpc instance, and run any tests we might have, which I'll just be running the default test. So in a terminal window, if you have Testrpc installed, you'll just run Testrpc, which will start your local Testrpc instance, and then back in your Truffle directory, you can just run Truffle test. What Truffle test does is that compiles your contracts and your libraries. It runs the migrations file, which links everything and deploys it. And then you have a test directory in your Truffle instance where you put your JavaScript Mocha tests in, and it'll run any of the tests that are in that. So I run Truffle test, and it compiles and deploys. Okay, so the warnings that we're getting here, that's something that they're fixing in the next update for Solidity, so it doesn't really mean anything. But as you can see, even though we added the library in there and changed the code, like what it looks like, everything still passed correctly, and now we have that extra check to make sure there's no underflow on that. And so then we would add it for the addition also, or any other mathematical operations you have. And that's something, especially like this math library, in any of your contracts, unless you can be 100% sure that there's no way for any overflow or underflow to happen, you should be using these safe math operations for any of your for any of your mathematical operations in your contract, just because you just want to be safe, because a lot of these, I mean, a lot of these contracts can be holding millions of dollars, or millions of dollars could be flowing through it if it's like an ICO. So it's just important that you make sure that you have all your bases covered, and that you're using these secure libraries. So I'm going to go back to this, So I just want to talk really quickly about Majoolr. Uh, so um, so I'm the one of the co-founders for Majoolr. I've got a business partner up in Fort Worth, and what we've been doing is we've been working on building. We started out building a suite of open source libraries for the Ethereum blockchain, and right now I think we have about 13 or 14 libraries that are currently deployed on the main test nets and then on the actual main Ethereum network. Because, like I was saying before, we think that there needs to be better coding standards and more security available to everyone, and we're hoping that we can get conversations started about what the best implementations of this functionality is, and find the most secure ways we can do everything. So, like we have all these libraries on all the networks. We've already deployed it. We've paid for all of that. So all that's required is that people just pick up the addresses on our GitHub, which I've written there. You just find the addresses in the ABI and the libraries, and you can just use them whenever you want. We've got standard array libraries. We have the math library. We have a string library. We have a wallet library, a multi-sig wallet library that we've actually we've deployed an instance of that we put about a little over $2,000 worth of Ether and tokens into, and had created like a little bug bounty basically, where we said like we released one of the private keys for it, and actually made one of the hackers of the parity wallets one of the owners, and said if anyone can hack this, they get the money. We find out if there's any issues with it, but we're pretty confident that there's no issues with it because we've done a lot of work on it. We also have a standard token library, which has all the functionality of the ERC20 tokens, and we've added a few more functions on top of that for like minting and burning tokens. And then right now, what we're currently working on are standard ICO libraries. So we already have just a regular direct ICO, direct Ether to token transfer out there. And we're working on one that's a more like distributed, even distribution crowd sale, and we're going to try to make a library that applies to all the main crowd sale models out there. And we're also, and then we're looking to leverage our libraries to make more secure Ethereum systems for the Ethereum blockchain in the future. So if you have any questions about that, or you need help with like an ICO or anything, you can come talk to me afterwards. But first, I'd like to ask if there's any questions about what we talked about today or about Majoolr. Yeah. 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 Mhm. Yeah. And one of the things that we also try to do at Majoolr is we try to make our documentation as good as possible, because that's something we really care about, because we've seen so many of these other projects out there. We've looked at their GitHubs, and it's really hard to tell what they're doing in their code, and like there's not good documentation standards. So we're trying to make sure that everything that we have is documented really well, and that we have clear instructions for how to use our libraries, how to deploy it onto the networks, and how to use the compiler and everything. So we hope that those are helpful for anyone using our libraries. But we are open to suggestions, so and we're open to collaboration if anyone wants to contribute on our GitHub to our libraries, because we're always looking for help adding more functionality to like the array libraries and the string libraries, because there's still more things to be added to that. So yeah.
What would you recommend for like a getting started guide with like Ethereum?
So I would say the Ethereum subreddit is kind of like the central hub for most of the discussion about Ethereum, and they have a post at the top of that that's like a introduction post. So if you want to get into Ethereum and development, they've got a bunch of resources on there. You can like look at the white paper. You can watch videos about Ethereum. They've got links to tutorials for Solidity, for Truffle, which is that development framework we're using. Almost everything you need, and then you'll kind of just everything kind of like branches out from there. So that's a really good place to start if you want to get into it. Yeah.
So when we first started using Ethereum and like deploying contracts, that was back before they had like Truffle and a lot of those. It was back when it was like all command line pasted in here. You know, like copy the API. Oops, I added like an extra character or something, and it's like, okay, it all fails. And when Truffle first came out, it sounded awesome, but it wasn't like ready. Would you say it's like at a stage now where there's not like setting up Truffle so it sort of works, and under these certain, do you think it's stable enough where it helps more than detract away?
Oh yeah, definitely. I mean, it's not perfect, but it just makes the whole process just like so much easier, because it like if you want to deploy your contracts, instead of having to go through all these like complicated things, putting in like the addresses in like the code of like the bytecode or the for your contract, you just put, like we were doing before, you put it in your migrations file, you put the deploy line in your migrations file, and you just type truffle migrate, and it does everything for you. And I haven't really had very many problems with it. I mean, there's some of the error messages on it are not very descriptive sometimes, which can be frustrating, but I mean, that's kind of what everything in Ethereum is like right now, just because it's still so early. But it's saved a lot of time, and I think it's very good.
So, do you know like a linter that would give you like linter or like warnings for overflow or underflow? Like, because I can imagine like pulling a bunch of code and basically just wanting to get a whole bunch of errors until I save and apply the entire thing. Is there a way to do that?
Not that I know of, but that would be useful. Yeah. Yeah. I'm sure there's probably something out there that somebody's working on, but I haven't heard of it yet. But yeah, that would be very useful. Yeah. Yeah. Anyone else have any questions? Yep.
The presentation you had the slide where you said that it was more expensive to deploy contracts than optimal libraries. It's actually cheaper to execute contracts on libraries.
Yeah.
So would it not be better to just always buy that upfront cost and then that would be cheaper to contract?
I mean, it kind of depends, because it would. I mean, if you do just like take that upfront cost, you also have to think about that. Like, if you want to update your contract, you're going to have to take that upfront cost every time you redeploy your contract, which could add up. And then also, it might just make your contract like bigger and more harder to like read and understand, instead of using. I don't know the exact numbers, but it is like fairly significant. Because like the most expensive thing in like when running transactions is storage. And so if you're having to deploy an entire like contract's worth of like whatever you had in that library that you were using, then that's going to cost a lot. Whereas if you're just using a library, that's already on there, and you only have to deploy the variables that you're using with that library. Does that make sense? Yeah. Okay, cool. Other questions?
Just to add on to that last point about libraries, like one place where libraries are especially useful is if you have like a system that has a factory that's generating tons of contracts, and the default way to do that is just, oh, I have this contract, I'm just going to deploy new instances of this contract. But if you're using libraries, then effectively you're just saying, I just need a new contract address with its own storage. But all the code is calling out to the same contract, so you're not reduplicating that every time. And that's the scale where it can really add up, where if you have thousands of instances of an identity contract.
Yeah, so like in our libraries, like for example, so this is one of our crowd sale or SEO libraries. So you can declare it's not actually storage for that contract. Like I said, since libraries can't have storage, but you can declare like the definition of like a struct that you can use for storage, and then in the actual contract itself, you initialize that you declare that storage and then initialize it using the library's initialization function. So for that entire, so this library, it has all of this, plus there's like another base crowd sale library which has functionality for all different types of libraries. So it's a lot of code, and then the actual contract itself just has this like constructor where you just pass in all the constructor arguments, and then just functions that you call that just call the library's contract. So once things get bigger and bigger, you save a lot by just using a library and just making your contract just bare bones function calls, and then any other small changes you might want to add to some of the functions. So it is very useful for that. And then also, one thing I forgot to mention, we were talking about upgrading libraries and contracts. You can't, like I said, you can't upgrade an already deployed library, but there are ways around that. So for example, you could have a contract that is kind of like a pass-through contract where you can store an address of a library in that contract, and be able to update an address every time you upgrade a library. And so then anytime people want to call your library, if you know you're going to have to be upgrading it, they don't even need to know when you upgrade it, because they'll be calling the contract that links the library to their contract, and you just update the address in that contract, and then that gets forwarded to the new instance of the upgraded library. So that's just one example. There's some problems with that, but like that's kind of like the gist of what people are trying to do with upgrading not only libraries but also for contracts.
Yeah, just real quick, I was wondering if you had any libraries that were kind of works in progress, or anything that was like you would like to see more libraries written for in the future.
Yeah.
So we have our array library is something that we have some like initial like functionality in it, but since before the Metropolis hard fork, you couldn't well, we still can because it hasn't happened yet, but you can't return dynamic arrays from function calls. So it made it really hard for us to write any functionality that had to return a dynamic array. So we just have like some functions that return like minimum value, or like return like a sorted array. Well, it doesn't return it, it just modifies this storage array. But there are a lot of functions for arrays that need to return arrays. So that's something that we need some help adding. Our string library, we've got a lot of functions in that, but that still could use more. Those are the two main ones, I would say, that we're looking for help with. But then also on all our other libraries, we still are open to like suggestions of how we can improve them, how we can improve the documentation, the testing, any extra functionality that could be added. So if you're looking to like help out, if you want to start contributing, if anyone wants to start contributing, you can find us at it's Majoolr, Majoolr.io is the name of our website, or you can go to our GitHub. We have a Discord channel that we're always checking and always communicating with people on. So if you have any questions, any about how you want to contribute, you can just throw a message on there, and we can help get you up and running, and with any ideas for stuff you can work on, because we've always got stuff to work on. Any more questions? Yeah.
Do you know of any projects that have these
Yes. So we're actually partnering with a few different organizations right now to run their ICOs. There's actually one starting, I think, in like 4 or 5 days. It's called Atheno. It's like a Ethereum casino. They're using our crowd sale libraries and and token libraries and like math libraries for their ICO. And then there's a couple other ones that are happening later in October and November that are also using those. And then we've got, I know a couple people have used our wallet library also for their multi-sig wallets. But we're kind of just like trying to get the word out there, because our libraries are the only libraries that are currently deployed on all of the networks, all the Ethereum networks. There are a few other people out there doing writing libraries, but none of them have the kind of documentation we have, and also have them deployed and ready to use on all of the test networks and the main network. So we're kind of trying to get our name out there and get more people to use it, because we're very confident about our libraries. Any other questions?
Yeah. So, during this next hard fork, are things going to stop working?
So with the hard fork, their goal in that is to make sure it doesn't break any existing functionality. I mean, there's still like a risk of that happening, but it's very unlikely, because I mean that would be really bad if they did the hard fork and it broke a bunch of people's contracts. So we're not really worried about that changing anything. All that's really doing is giving us more tools that we can use in our libraries. Like if we wanted to return dynamic arrays, like I was saying before, or use the Zcash, like zero knowledge proofs in our transactions. But we're not worried about the hard fork affecting us at all. Yeah.
That one also, I think it's because you're not just adding the stuff on the compiler so you get new opcodes or whatever, but the actual nodes and stuff they're validating, they're also upgrading. Yeah. So it's a little bit easier to do that backwards compatibility that way.
Is it the hard fork? Yes, the hard fork is live.
Yeah, on the Ropsten testnet right now, it is live. We haven't experienced any issues on that, and we've been testing our token library along with the crowd sale libraries on Ropsten and Rinkaby's still on Homestead. So we haven't experienced any issues with Ropsten yet. So we're not too worried. Yeah.
But you remember when there was a testnet a year maybe or two ago that died?
Or
yeah, so somebody, we were in a hackathon and it died the day of, and I was like, what? Does anybody know what ended up? Did they just lose all their miners basically?
Got DDoS.
Okay.
Yeah. And it just got DDoS, and people still try to DDoS the Ropsten testnet. But well, they do.
Smash. Yeah.
which is why Clover has such a new.
That's right.
That's right.
All right. Any more questions?
Thank you.
All right. Yeah, I'll be here.